For the reaction, nitrogen pentoxide, dinitrogen pentoxide, or nitric anhydride. Yeah? Then I have nitrogen dioxide, I have oxygen. At the time when nitrogen pentoxide or the nitrogen pentoxide is being consumed at the rates of this. So they're asking me to say, see what they're asking me? They're asking me that this is a reaction which is and this decomposed to give me. So they are asking me, the question here is now, what is the rate at which oxygen is being formed or is being produced? What is the rate at which O2 is being produced? So whenever you see such a question, the formula I want you to use is this. So K times product all over K reactant, or you can use K of reactant all over K of products. And K is rate of consumption or rate of production. So we can say K of products. And here they're talking about O2, K of products. And the rate of product that we use is simply, we use the coefficient. Here oxygen is having coefficient of 1, which is equals to 1, all over that of the reactant, what is decomposed, which is K of reactants. I know that it tends to diminished, which is equals to the stoichiometry there, the mole. Remember I taught you stoichiometry. The mole here is 2. So times the rates all over, times rates of reaction. So times rate of reaction. And the rate of reaction here is simply 1.2 times 10 raised to power minus 6 mole. This thing you see here, M over S. They are saying molarity. Molarity over S. And you know that molarity is the same thing as saying mole per liter per second. So mole per liter per second. So that is rate for you. So times 1 over 2. So this is the formula you always use. The formula you always use is simply the coefficient of what you are asked to find. Fine. All over what you are given. What you are given times rates of reaction. So when you do it, you can see very well that if you do it in this case, you now have that this is the same thing as saying 1 over 2. Okay, let's just multiply. So this is the same thing as saying 1.2 over 2 times 10 raised to power minus 6, which is equals to 0.6 times 10 raised to power minus 6 over 10. So this is the same thing as saying 6 times 10 raised to power minus 1 times 10 raised to power minus 6. So this is the same thing as saying 6 times 10 raised to power minus 7. Then molarity per second, or mole per liter per second. So that's your answer. So the way to go about questions like this, where you are asked to find the rate at which, should I say, when something is being consumed, they are now asking you to find the rate at which something is formed. Or you say I call this rate by stoichiometry. So finding rates by stoichiometry, or finding the rates from an equation, or you say rates by stoichiometric coefficient. So whatever you are asked to find, that is what you place against the other one. See, for example, in this second part, okay, we now know this. Let's move to this part. What is the rate at which NO2 is being produced? Remember, let's notice something. This part, oxygen is production plus. This part is minus. That is product plus. This part minus. Then notice that is consumed. This is being consumed at rate 1.2. So I put minus here. By the time you times, minus will change to plus. So no use. So they said, what is the rate at which NO2 is being produced? From the same question. Remember that this is the equation. That is 5b. You have N2O5 nitrogen pentoxide. We have nitrogen dioxide plus oxygen. Equation must be balanced. Okay, let's check something. How did I come and put 2? Where did I see 2 from? See here. There is no 2. So this is 1. I don't know where I got 2 from. This is not supposed to be here. It's just like this. So just like this. So that's a mistake. It's just supposed to be O2 because this is the question we are given. This is the balanced equation. See, I have 2 times 5, 10. Then I have here 2 times 4, 8 plus this 2, 10. So this is the balanced equation. So now they're asking us what is the rate at which one this one is being produced. Remember that we are given a rate of consumption. And rate of consumption here is being, this one is decomposing at 1.2 times 10 raised to the power 6 minus 6. So we'll simply do oxygen here, the coefficient of nitrogen here is simply 4. And that is what we are asked to find. Assuming they asked us the rate of this one, we'll use this one against whatever it is. So this is 4. Why? This one is the one getting decomposed. All over 2. Then times the rate. So I told you the ratio of the coefficients. Or you say the mole. If it's not given a mole, you take it to mole. The mole, no, this represents mole. This is 4 moles of NO2 times the rate, which is 1.2 times 10 raised to the power minus 6. So 2 here 1, 2 here 2. So 2 times 1.2 is 2.4. It's 2. So yes, 2.4 times 10 raised to the power minus 6. And if you put 10 here, this can be distinct as saying 24 times 10 raised to the power minus 1 times 10 raised to the power minus 6. So this is also 24 times 10 raised to the power minus 7. Whichever way you want to do it, you can leave your answer this way or this way. So mole per second. Okay. So the simple trick there is simply mole, or you say coefficients of which is produced or consumed all over mole or coefficients of which or of whose rates is given times the rates times rates. So this is the formula. This is the formula you need to know.